2017 was a busy year for scientists of all sorts, the professional and the enthusiast alike. From a predictable astronomical rarity to surprise discoveries deep underground. It was a year that saw long-held beliefs challenged by newly found wonders, breakthroughs that led to innovations, and a glimpse 130 million years into the past. In August 2017, alarms sounded at the most sensitive scientific devices ever constructed. In Washington State, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected faint disturbances from deep space. The signal also hit LIGO's sister facility in Louisiana. Gravitational waves had reached Earth.
Gravitational waves are ripples in space-time. Space-time is incredibly dense. So to cause ripples, you have to have some sort of object that has enormous gravity, like a black hole or a neutron star. And when these objects are rapidly accelerating, they bend space-time and create these ripples that then travel through the universe to our detectors on Earth, like the one last August.
On high alert, the LIGO team quickly reached out to Virgo, its European counterpart in Italy, who confirmed that they too had detected gravitational waves. And then, as if by destiny, the stars would align once more to pave the way to a groundbreaking discovery.
Just 2 seconds later, with the Fermi Gamma Ray Space Telescope, we detected a short, bright flash of high-energy light that we call a gamma ray burst. This alerted the entire astronomical community to the fact that something very exciting was happening.
Using data collected from LIGO, Virgo, and Fermi, 70 ground and space-based telescopes scoured the edge of galaxy NGC 4993, some 130 million light-years away from Earth, searching for a small flash of light amidst a sea of stars. It would take less than 12 hours after the alarms rang at LIGO for Earth to have visual confirmation of a never-before-seen astronomical event.
What we saw was the result of the merging of 2 neutron stars. When they merged, they created an explosion in space-time. Those ripples went out across the universe as gravitational waves and were detected on Earth. The matter involved gave off gamma rays and other forms of light.
Neutron stars are the collapsed cores of massive stars left behind after a supernova explosion. No larger than a mid-sized city, these dense stars have 10 to 60% more mass than our Sun. This pair of stars, 200 miles apart, were locked in each other's orbit for over 11 billion years. But as they started accelerating and moving inwards, their orbit quickened from 30 times a second to an astonishing and unsustainable 2,000 orbits a second. Then, 130 million years ago, they collided in a resounding explosion. Peering into the past, telescopes were able to see the remnants of one of the universe's most impressive fireworks shows. A bright flash of blue followed the initial explosion, growing redder and duller as the days passed, until eventually fading to black.
The conditions around these merging neutron stars have densities and temperatures completely unlike anything we can do on Earth.
The violent explosion was observed to have produced 200 Earth masses worth of gold and 500 Earth masses of platinum, revealing for the first time the origins of heavy metals in our galaxy.
We think that all the gold in the universe was formed in explosions of this kind. After the explosion happens, the gold is spread out into the gas and dust of the interstellar medium. Later on, that gas and dust collapses into brand new stars and brand new planetary systems.
And these weren't the first gravitational waves detected by LIGO this year. 2 separate events have been measured before, including a pair of monstrous black holes that collided to form a single spinning hole, 53 times more massive than the Sun.
We received a perfect signal from this last merger. It traveled 3 billion light years to get here. In any given galaxy, one of these events might only happen once every million years, but we're now able to monitor about 10 million galaxies at a time. It's a new type of astronomy.
But while we wait for gravitational waves that can open a window on the origins of our universe, volcanic activity off the coast of Japan is presenting scientists with a picture of Earth's early history, when land first rose from the seas. Violent eruptions spew a steady stream of lava and rocks, expanding the newly emerged island of Nishinoshima, 3 square kilometers, in just 5 short months this year. These most recent blasts stopped in August, but could resume at any time. Situated atop the junction of 4 tectonic plates, the Japanese islands offer stunning insights about the formation of a variety of landscapes. Analysis of Nishinoshima's magma shows it to be andesitic, similar to the composition of continental crust. Monitoring the growth of Nishinoshima, geologists hope to learn more about the forces that led to the birth of the world's 8 continents. Yes, not 7, 8. In February 2017, the Geological Society of America published a startling paper. Zealandia, Earth's hidden continent. Geologist Nick Mortimer was the lead author.
To discover Zealandia is to change the map of the world, quite literally. Beforehand, most people would say, yes, we've got 7 continents, they could count them off. But now, the world map's changed and we've got an 8th one on there.
In the beginning, there was no search for Zealandia. Mortimer and his team discovered the shallow submerged continent while performing geological work aboard a research vessel off of New Zealand's coast.
And so what the various geological investigations have led us to is that we do have the components of a continent here. When you pull the plug on the world's oceans, you literally reveal the continent of Zealandia.
Mortimer and his team confirmed 4 geological markers, the qualifying criteria for a continent: height, a varied geology or diversity of rock types, a thick crust, and ultimately size. Is it big enough? Corroborating data include rock samples, ocean drill cores, and satellite microgravity measurements, translated into bathymetric or elevation maps of the sea floor. Situated between the Pacific Plate and the Australian Plate, tectonic forces squeezed Zealandia, raising out of the water what we know today as New Zealand. With 94% of Zealandia underwater, the islands of New Zealand and New Caledonia are just the tip of this continental iceberg. And measuring in at 4.9 million square kilometers, Zealandia is 6 times bigger than the so-called microcontinent of Madagascar, and more than twice as large as Greenland, which also happens to be attached to North America. To understand Zealandia's origins, we must travel back in time to the time of the supercontinent Gondwana, comprised of what we know today as Africa, South America, Antarctica, and Australia. When Gondwana split apart 80 million years ago, it was a bit like the stretching of bread dough in a kitchen.
And then you start to pull that big lump of dough apart. And if you pull slowly, some of those pieces will stretch and get thinner.
just like Zealandia, which broke off and slowly sank because of its relatively thin continental crust.
It's not as thick as the main continents, but it is thicker than the ocean crust. And geophysicists know that when you have thin crust, it floats lower in the mantle, and so it sits lower elevation-wise, and that explains, in very simple terms, why Zealandia is so submerged. Now that we've got Zealandia in the scientific arena, we do hope to consolidate it and to promote Zealandia in New Zealand schools, first of all, and we hope to get it in atlases, on globes. We hope that Zealandia will become as common and well known as any of the other major continents.
Of course, the initial buzz about Zealandia can only help its name recognition.
The notion that something so big and so important could be hidden for so long, I think captured people's imagination.
Out of sight, out of mind, no more. Of course, not everything that's undetected is so obviously obscured. And one remarkable discovery this year offers clues about how some prehistoric creatures could hide in plain sight. In northern Alberta, Canada, the remnants of a 110-million-year-old dinosaur from the late Mesozoic era is providing the world with an unprecedented look at a new species, the nodosaur. A fossil so pristine and complete that it shows the texture, patterns, and color of a prehistoric giant.
The nodosaur is the best specimen we have, and it's the closest you'll come, until we find a better one, in terms of coming face to face with a dinosaur.
The nodosaur is next to surreal. A petrified beast caught by Medusa's gaze.
We knew it was good, but we didn't know how good it was. I think it's the best preserved armored dinosaur in the world. I'm calling this the Rosetta Stone for armored dinosaurs.
The anatomy of the new species has already given scientists clues to how these animals evolved, how they radiated and diversified through time. And it doesn't stop there.
The skin is preserved. It's not just the impression of the skin. We actually have some of the original biomolecules preserved. One of the cool things that they tell us for this specimen is that the animal had at least a component of reddish-brown pigment to its skin. The coloration aspect is very exciting. So it's cool to know what color it was, but it's actually more exciting when that has some implications for how the animal lived.
Researchers believe the nodosaur was darker on the back and lighter on its sides and underside, a method of camouflage called countershading.
Now keep in mind, this was a 5.5 meter long, 10.5 animal covered in armor, but it still has camouflage. And to us, that just illustrates how intense the predation was back in the Cretaceous. You had these very large meat-eating dinosaurs, and they would have also been very visual predators. So it actually kind of just shows you how extreme that ecosystem likely was back in the Cretaceous.
The plant-eating, slow-moving beast only stood a chance because of its impenetrable coat of armor.
We see 3 rows of osteoderms. Those are what are called cervical rings, and it's armor that would have protected the neck of the animal. And as we move to the side, we see this giant parascapular spine. It's basically a big armor spine coming off the shoulder, and it's about 1/2 meter long.
And the spectacular specimen still has many secrets to unveil. The next focus of study are the contents of the nodosaur's stomach.
In addition to having skin preserved all over most of the surface of the animal, we also have abundant gut contents. So the last meal of the animal preserved inside. And this is what that stuff looks like. So we're currently doing all sorts of work on this, geochemical work, histological work, and CT scanning, trying to figure out what these spheroid structures are. And there's been many ideas that part of the diversification of dinosaurs is tied to the diversification of flowering plants. And it would be great to see exactly which types of plants this guy was eating, and if that hypothesis makes sense.
We know what dinosaurs ate, how they fought, and now what they looked like. But there are still many questions to be answered. And Alberta might just be the place to find them. It's estimated that there are thousands of fossils hidden underneath the Earth. But when a 6-mile-wide asteroid struck the Yucatan Peninsula 65 million years ago, dinosaurs had nowhere to hide. And the resulting global cataclysm of earthquakes, firestorms, and tsunamis ultimately led to their extinction. Some animals, however, managed to survive. But how? Since its discovery in 1978, investigations of the asteroid's impact crater include data from seismic images and recently collected core samples from deep within the site at Chicxulub. The data paints a devastating picture of destruction and led scientists to create a broad new survival theory, focusing on habitat and diet adaptability. When dinosaurs perished and a vast new ecospace emerged, the surviving species expanded rapidly to fill it. This is called adaptive radiation. A recent study shows that 1 out of 10 frog species descend from the original 3 frog species that survived the Cretaceous-Tertiary extinction event. Frogs were able to escape extinction for a number of reasons. They live in an aquatic habitat that offered protection. Their small size and unique metabolism allow for better endurance of environmental stress. Eventually, when vegetation returned, they were able to diversify worldwide and adapt to new lives in trees. Birds, too, exhibited the same adaptive radiation around the same time. A newly found 62-million-year-old mousebird fossil in New Mexico helped paleontologists map the diversification of land birds, which can be traced back to 9 original ancestors which survived the event. Warm-blooded, birds' feathers insulated them from temperature extremes. Their small size and ability to fly allowed for easier escape from hostile and barren terrain. And their diet of seeds, worms, and insects gave them the edge after much of the Earth's surface plant life had died. In the end, the ability to adapt to changing conditions proved a key characteristic for the survival of many ancient animals, including our smallest mammal ancestors. Just as it may be for humans today, as we confront the challenges of climate change. The city of Miami Beach already knows what it means to wade through sea level rise. In recent years, residents have experienced elevated high tides at certain times of the year. Known as king tides, these events are clear evidence of incremental increases.
Right now, we are definitely witnessing sea level rise impacts, these high tide flooding events that are growing in severity, more often, deeper, more widespread. That's sort of a pattern that we expect will continue.
That means huge financial costs by the year 2100. Another predicts 2.5 million Miamians could become sea level refugees and leave the area. It's not only Miami. All around the world, sea levels are expected to rise. The question is, by how much? In adopting a multi-pronged approach, Miami Beach has committed $400 to $500 million to combat sea level rise. building water pumps and raising their defenses.
With the continual issue of climate change and sea level rise, we're seeing an increase of water level every year. We had to make changes to adapt to this future condition. What you're seeing here, we put a boardwalk initially to give some height, but we found that that wasn't protecting the city. What we've done here is we've increased the levels of our new seawall. The new wall you see in the background here is our new standards. This is good for approximately another 50 years, and we're going to see water levels challenging even that new seawall.
Raising its elevation, Miami Beach seeks to stay dry and take control of its future.
The city's philosophy, our culture, is rising above. We believe we can meet the challenge. And the challenge is not only in rising above, meaning elevation, it's rising to and withstanding the challenges that come with sea level rise due to climate change. As a city engineer, I have complete faith that we can win. We can mitigate. We can survive.
Of course, the Earth's oceans have risen and fallen many times during the planet's history. And new archaeological evidence suggests these shifting shorelines may conceal clues about the earliest Americans. Until just recently, archaeologists generally agreed that the earliest people to populate North America were the Clovis people, dating back to some 12 to 13,000 years ago. But a group of scientists in San Diego, California, have a different theory.
We have the bones, the fossils, the distribution, the rocks, the date. We have evidence for humans in North America 130,000 years ago. We realize that that is a startling claim.
But the scientific community is struggling with the idea that humans arrived in North America 130,000 years ago.
The study of early humans in the New World has been very political and very controversial for over 125 years.
It's an old mystery yet to be solved, deciding who got to North America first and when.
Welcome, and thank you for joining us this morning at the San Diego Natural History Museum as we share some exciting news about a discovery made right here in San Diego.
Well, back in 1992, Caltrans was doing improvements to State Route 54, which involved adding a couple new travel lanes. And Richard Cerruti, who's a field paleontologist here at the museum, was monitoring excavations on the very north side of the freeway alignment and saw this little puff of let's say, tusk material being scraped up by an excavator and said, "Stop, let me go look at this."
The bones that Richard Cerruti found belonged to an ancient mastodon.
That's one tooth, and it's characteristic of American mastodon.
Were these giants sharing North America with early man 130,000 years ago? The answer may lie in the position of the bones and tools found at the site.
There are anomalous fragments of rock, anomalous fragments of tooth enamel scattered throughout the site that just don't make sense.
Could these stones amongst ancient bone remnants have been an early form of primitive tools?
And we felt that it was important to produce a map where we carefully plotted or precisely plotted the position of all the bones and the stones or whatever else is in there, so that we can understand what the general pattern is.
It's thought that the tools found with the mastodon bones were used for butchering the animal.
So this is one of the cobbles that we hypothesized was used as a hammerstone. 130,000 years ago, where there was a carcass of a mastodon. These people were trying to recover raw materials from it. They had a problem. How do we break these bones? They look over into the active river channel, find some cobbles of the appropriate size and weight, bring them back to the site. And if you look closely, there's some striations coming off of that are indications of where this flake has come off.
The cuts in this rock led the San Diego team to conclude that these were actually tools used by humans. An idea that Demir says might not be so far-fetched. Dr. Stephen Holen is co-director of the Center for American Paleolithic Research in South Dakota. He was part of the team that evaluated the findings from the San Diego excavation site.
So what do we got in here, Steve?
Looks like vertebra.
It does.
I said, I can't get my mind around this. This site has to be really, really old, but yet here's evidence of humans. I said it goes against everything I thought I knew and everything I have ever been taught.
Holen evaluated the mastodon bones and the stone tools recovered from the excavation site.
We would take the drawers out of the cabinets in here and bring them in on this table and look through them, paleontologists and archaeologists together. Richard Cerruti came in, so there were 4 of us, my wife Kathleen, Tom, and I, and we would look through and we would look for these very diagnostic pieces. And one of the things that we got all excited about first were these cone flakes that form in a circle around the point of impact from the hammerstone. And based on the experiment that we'd done in Africa, breaking an elephant femur with a big hammer, we saw the same kinds of fracture patterns that we did experimentally.
Holen specializes in evaluating broken bones at archaeological sites, looking for human causes, as this video shows from a test he conducted in Africa 2 years prior to working on the San Diego project.
Oh my God. As we puzzled over this, we kept coming back to this one explanation that explains all the data, was that humans did this.
The detective work by the San Diego Natural History Museum team was capped by the age dating that Richard Cerruti had done to prove the age of the mastodon bones he discovered.
This is one of the specimens that he used in his analysis. He cored it and he also sliced it. And after analyzing over 100 microsamples from this specimen and 2 other specimens of bone from the site, yielded an age of 130,000 plus or minus 9,000.
So after the article came out, there has been no critic come out to say that the dating is incorrect. In fact, other specialists in uranium series dating have come out and said the dates look perfectly good. So we're very comfortable with the dates.
While humans' arrival in the Americas may have occurred earlier than previously thought, new dating of another paleontological find, found in a South African cave, could soon upend long-held theories about the evolutionary tree of primates and early humans.
When we actually got into the chamber and could start removing it, we realized that not only was there one individual lying there on the surface, but the floor was literally comprised of Homo naledi. There are thousands and thousands and thousands of remains down in those chambers, and all you have to do is sweep the surface off, and there they are.
So the first time I sort of slid through that hallway into the open area where the chamber is and sort of started looking around, you know, you're only wearing a headlamp, so you just see flashes, but every flash of my headlamp showed bone. So I think right at that point, I realized that we had a lot more than the original photographs actually had portrayed. So that was pretty exciting.
Homo naledi isn't really similar to any known hominid species in its entirety of its package. You've got little bits and pieces of almost everything we've ever found. Parts of the skull, if you just look at it quickly, look a little bit like Homo erectus. Got a very small brain. Other parts of the skull look very modern, like Homo sapiens. It gets stranger and stranger as you move down the body. You get the ape-like shoulders. You get these more and more human-like arms, which end with a hand that's human proportion.
I was actually at the London Natural History Museum, and Homo naledi was on the wall, and then there was estimated age between 1.2 and 1.8 million years. But then, when we actually did the scientific dating of those teeth, this is when things got very interesting, because then we got an age of 200 to 300,000 years old.
When we got a date, it was much younger than that, 250,000 years, give or take, we realized that we were dealing with a primitive creature, almost like a time traveler, that had come down from deep times to a point where it is very possible that Homo naledi was in direct contact with the emergence of modern humans. We never thought that was possible in Africa. Until this moment, we thought that there was effectively, during that entire time period of the Middle Pleistocene, late Middle Pleistocene, one form, a big-brained form of Homo sapiens. Now there are 2, and that adds incredible complexity to our record.
The world of Homo naledi and other early humans was different than it is today. A veritable Garden of Eden, teeming with life, pure and free from pollution. Few places like this still exist, and most of them quite remote. But look just a few feet underwater and you can find one of the most productive and overlooked ecosystems on Earth. Scientists recently learned that seagrass meadows help scrub the surrounding water clean of bacteria from raw sewage and other pathogens. A recent study of polluted waters in Indonesia showed levels of harmful bacteria to be 50% less in spots with robust seagrass beds, leading to healthier fish and coral in the surrounding area. You see, seagrasses oxygenate the water, trap sediment that might otherwise float freely, and host tiny microbes that kill many harmful bacteria. Eliminating toxins improves the health of any system, and the workings of a human body is no different. In athletics, though, they say no pain, no gain. A nod to the physical effort required to increase endurance and enjoy the health benefits of exercise. But new pharmaceutical research also aims to make those benefits more easily accessible.
The potential benefit of a drug that can tune you up in the way in which you normally get tuned up by exercise could have really dramatic effects.
Playfully known as the exercise pill, the experimental drug shifts metabolism by triggering genetic instructions for the body to burn fat instead of sugar during exercise, something that doesn't normally happen until after extensive training and conditioning. Recent tests increased the endurance of otherwise sedentary mice, which also proved to be resistant to weight gain while on the drug.
We have two groups of mice, and one group on the drug, the other group as a control without the treatment of the drug. So we were quite surprised to see the astonishing results. The mice treated with the drug, they can run almost 100 minutes longer than the one that are not treated. The increase was around 70%.
Researchers ultimately hope their product can improve the health of the disabled, elderly, and obese.
There are many reasons why people can't either walk or run or exercise. And the idea is if you can bring a small molecule into the picture that can confer the benefits of fitness without training, you could really help a lot of people.
From energizing our bodies to powering societies.
So we are just waiting for the next experiment. It's going to happen in 10 seconds. There you go. You see the flickering of the plasma? We are creating fusion here. This is our little sun. It's extremely hot.
Each day, every 20 minutes, researchers build the sun. At the Culham Fusion Centre in Oxfordshire, Britain, generating temperatures greater than 200 million degrees, these nuclear fusion trials would be impossible without JET, the Joint European Torus, a donut-shaped plasma containment vessel.
At this point, we're the most important experiment in the world.
Thanks to JET, where energy is created by combining hydrogen atoms.
Right? There's heavy hydrogen, which we call deuterium, and the super heavy hydrogen, which we call tritium. And when they're running around at these temperatures like 200 million degrees, they bang into each other with immense speed. And when they do, and they get close enough, what we call the strong force, which binds the nucleus of atoms together, grips them, pulls them together, and they fuse, and they make helium, and they spit out a neutron. Fusion really is the perfect way to make energy.
And yet, despite fusion's transformative potential to provide safe and sustainable energy to the world, the program faces an uncertain future. while the British government committed to pay for its share of the experiments up to the year 2020, Brexit, its planned departure from the European Union, may also lead to the UK's withdrawal from scientific agencies like Euratom, the European Atomic Energy Community. Some say this could jeopardize jet logistics and operations, and perhaps also the larger next-generation fusion experiment, currently being built in southern France. If fusion represents harnessing the physical power of the sun, a moment of darkness reflected its emotional power. An awe-induced euphoria experienced by millions as the first total solar eclipse over North America in 3 decades made its way across the United States.
It's the most unnatural natural phenomenon I ever saw.
This is a solar eclipse, and just what people witnessed on August 21st along a 70-mile wide path. First along the Oregon coast at 10:15 a.m. Pacific Daylight Time, and last in South Carolina 94 minutes later. The uncommon coupling was the most viewed and photographed eclipse ever recorded. And yet, even as the sun re-emerged from the moon's shadow, some earthly domains remained, as always, far removed from its rays. Like the cave chambers, 300 meters below Mexico's Nica mine, enormous razor-sharp crystals dwarf human explorers. While today the cave is totally submerged, previous expeditions collected bizarre life forms from these crystal giants. They call this place Hell on Earth. Temperatures climb to 135 degrees Fahrenheit, with over 80% humidity. Even with life-saving bodysuits, no visit can safely last longer than a half hour. Yet deep within this extreme environment are life forms which exist nowhere else, known as extremophiles. NASA astrobiologist Penny Boston and her team found 40 strains of mineral-eating organisms trapped within the crystals here. They collected sample microbes, some dormant but alive, estimated to be between 10 and 50,000 years old, including genetically unique and previously undiscovered life forms.
Any extremophile system that we're studying actually, allows us to push the envelope of life further. And we add it to this atlas of possibilities that we can apply to different planetary settings.
By expanding the definitions of life on Earth and where to find it, Boston's findings could impact the search for life beyond our planet. On places like the protoplanet Ceres, the largest object located within the solar system's asteroid belt, and one of the scientific targets of NASA's Dawn space probe. And in February of 2017, startling and unexpected news began coming in.
My colleague found a spectral signature in her data that is consistent with, or the same signature of aliphatic hydrocarbons. So here we're finding maybe the building blocks of biological material.
Seen here in red, the organic materials are thought to have originated in the dwarf planet itself. Dawn's study of Ceres also revealed evidence of water and volcanic activity, further raising the scientific profile of Ceres, no longer considered a barren rock. However, Dawn isn't the only NASA spacecraft uncovering new surprises about our solar system. Seven months after arriving in Jupiter's planetary system, the Juno Explorer became fully operational in February of 2017. Astonishing researchers with the steady stream of images and scientific data it's sending back to Earth. Jupiter is by far the largest planet in our solar system, leaving Juno with a whole lot of ground to cover. And although it is the second brightest planet in our night sky, its formation and composition have left us in the dark. Previous NASA missions have given us some understandings of its moons, small dust rings, and atmosphere. But we've not been able to see past the Van Gogh-like swirls of dense red, brown, yellow, and white clouds that paint the planet. At least, not until now. Each individual image is awe-inspiring, especially those captured when Juno came within 5,000 miles of Jupiter's Great Red Spot, the planet's most famous storm. Poring over data from Juno's microwave radiometer, scientists hope to learn more about what powers the Tempest and how it differs from other Jovian storms. This critical instrument measures 6 distinct ranges of thermal radiation as it peers more than 300 miles beneath Jupiter's clouds to create a three-dimensional model of Jupiter's atmospheric environment.
So the first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different.
Current modeling estimates that the cloud cover is roughly 30 miles thick. Below it, there lies a 13,000-mile layer of swirling hydrogen and helium that changes states from gas to liquid as it nears the center, leading to a 24,000-mile deep sea of metallic hydrogen.
And if we can probe it and work out the abundance of elements in it, hydrogen, helium, the higher elements as well, and work out roughly what that mix is, it'll tell us something about not only how Jupiter was formed, but how the solar system might form.
If there is a bunch of rocky material in the center of Jupiter, it means that in the early solar system, before Jupiter formed, that rocky substances were probably coming together and Jupiter got built around those. It could be that Jupiter was built without any of those and that it just collapsed sort of like the sun and there is no rocky material or core of heavy elements in the center.
Strangely though, gravity data collected so far points to a new possibility. A somewhat larger than previously thought and perhaps partially dissolved core, leaving Jupiter experts with more questions than answers.
We're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet.
Juno's primary mission is scheduled to continue until February 2018. But this past year, NASA saw another of its extraordinary explorers come to the end.
And we are in the atmosphere.
As the Cassini space probe plummeted into Saturn's atmosphere in a fiery death spiral.
Roughly 1 minute to loss of signal.
The culmination of the craft's revolutionary scientific quest.
Call loss of signal at 115546.
The signal from the spacecraft is gone. Congratulations to you all. This has been an incredible spacecraft, and you're all an incredible team.
She has rewritten the textbooks about Saturn, the rings, the moons, Titan. So many things have changed because of Cassini.
From its launch 20 years ago to its bold grand finale, the Cassini-Huygens mission has unveiled some amazing discoveries. Saturn is ablaze with storms of unimaginable force. the place crackled with giant lightning strikes. The rings are even more dazzling than imagined, stretching across hundreds of thousands of miles. They're made of particles of pure water ice, some microscopic, some the size of mountains.
They break apart and they reform, so there's this beautiful cosmic dance going on inside the rings.
Cassini also carried a little lander called Huygens, which became the first probe to land on a moon other than our own. Its target, Titan, because of its atmosphere.
And as those first pictures came back, we just saw more and more haze and fog and haze and haze, until finally the probe broke through that haze and we got to see the surface of Titan for the first time.
Huygens landed on the surface of what looked like a mud flat. The surface temperature was minus 350 degrees Fahrenheit, and these pebbles were made of methane ice. The nearby lake, a lake of methane.
Then Cassini went into orbit around Titan and revealed with his radar system that there indeed are lakes of liquid natural gas and other molecules on the surface of Titan. They evaporate, just like here on Earth, create clouds of methane which rain back on the surface, creating rivers of liquid natural gas and lakes.
Could there perhaps be some very interesting life in the lakes on Titan?
But there were dry formations here too, including dunes that stretched for miles and miles, reaching 100 meters high, and 3,000-meter mountains, suggesting tectonic forces at work here, similar to those on Earth. Next, Cassini headed for a close look at Saturn's tiny moon called Enceladus. Here, on the moon's south pole, strange blue cracks, dubbed tiger stripes, 75 miles long and hundreds of feet deep, resemble fault lines here on Earth. Cassini's thermal sensors picked up heat coming out of the ice ball, 200 degrees warmer than the rest of the planet. Cassini then captured giant jets of water spewing hundreds of miles into space from the tiger stripes, shooting out at 1,200 miles per hour, vaporizing and then freezing. Back on Earth, Cassini's stunned controllers quickly reprogrammed the probe to fly right through the jets, collecting particles. And what they found was even more stunning. Organic molecules, the basic building blocks of life.
Enceladus is really special. It's giving us free samples.
Because the geysers are erupting and they could guide the spacecraft very close and look to see if there's water there, and there is water. Here on Earth, wherever there's liquid water, whether it's deep in the ocean and very hot or in rocky places or in ice, there's microbial life. So it certainly suggests microbial life could have evolved on Enceladus because it has all of the properties that the Earth had when life began here.
NASA controllers plotted the probe's deadly descent into Saturn's atmosphere. Productive until the end. Cassini relayed detailed information about the planet's environment. And then she burned like a meteor and vaporized. Scientists will build on Cassini's contributions as the search for extraterrestrial life continues within our solar system and beyond. Perhaps around the star system 39 light-years away, known as TRAPPIST-1. The first place found, NASA announced, to have multiple planets. 3 here, circling a single star inside the habitable zone, where liquid water can exist.
Well, with this discovery, we've made a giant accelerated leap forward in the search for habitable worlds and life on other worlds, potentially speaking. The TRAPPIST-1 system has really captured our imagination because with this amazing system, we know that there must be many more potentially life-bearing worlds out there just waiting to be found.
Earth-like in size and temperature, these three faraway worlds suggest endless possibilities.
The discovery gives us a hint that finding a second Earth is not just a matter of if, but when. These questions about are we alone are being answered as we speak in this decade and the next decades. So I'm really excited about this.
It's been an astonishing year for sure. And as our universe reveals more of its secrets, far out in space and closer to home, our foundation of knowledge will continue to grow, promising ever more to come.